afternoon, fellow teachers and students, and good afternoon, model class. Okay, thank you. You may sit down. Okay, that is our topic. Subtopic is force and gravity. Right? You already learned something on acceleration due to gravity, and that is from our last lesson, especially when we were studying kinematics. Right, so there is nothing new on this topic, just a force of gravity, and much of that has been done in the first, let's say, we studied, and this is the unit on force and motion. So I'd like you to go through in this. Just have the notes down quickly, and there will be also the acceleration due to gravity, especially on different parts of the planet and the moon. And given this, you can be able to use it to calculate, let's say, the force on each of these. If someone, or let's say even an astronaut, is out there. If you can be, or if you can remember our last lessons, especially on mass and weight, right? The mass is simply the amount of matter in an object, while the weight would be the force of gravity on an object. So sometimes we tend to use these two terms together. Weight and mass. What is a weight? Someone would give you that in kilograms. That is, especially when you are studying physics, that is wrong. The weight is a different quantity, and the mass is also a different quantity. Okay, we'll move on. Mass is quite a very, very difficult thing to measure, but there are instruments that we can use to measure that. Mass is talking about the amount of material, especially which are in this. For example, if I'm holding this eraser, or let's say the whiteboard eraser, if you had to cut all of this up, probably into very, very small pieces, then if you have to combine them together, they will always give you the same mass. Okay, so it is talking about the amount of matter in this. Okay, we will move on. Using the second law of motion, all right, we only have to replace the symbols there, which is F is replaced by the letter there, which is W, and A is replaced by G, which is the acceleration due to gravity. Okay, there's the same quantities. Okay, weight is the same quantity as the force. Sometimes you might be confused with that formula. It is the same as force equals to mass times acceleration, but this time, because it is falling from a certain height, we tend to use this formula. All right, these are the acceleration due to gravity for different planets and also on different part of the planet. All right, the Earth has one moon, and man has already landed on the moon. One of that given, or they measure the acceleration due to gravity to be 1.6, or about 1/6 of the acceleration due to gravity on Earth. So 1/6 of 10 would be about 1.6. And you have Mercury, which is about 3.7 meters per second square. Venus would be 8.8 meters per second square. You have Mars, which is 3.7. Jupiter will be 24.9. And you have Saturn, which is 10.5. Uranus has 7.8 meters per second square, and Neptune is about 11.8 meters per second square. All right, so considering these values, let's say we decide to drop an object in Jupiter, it will be more faster than the Earth. Okay. Because the acceleration due to gravity will be about 24.9 meters per second square. Just imagine how far or how fast it will fall because of the acceleration. And even the force on that will be quite high because it is about 24.9. Alright, some of you may have seen pictures of people who are floating, especially in space or in moon. Probably they are not, okay, sometimes people just mention they are moonwalking, meaning that they are not actually on the ground, just because the acceleration is acceleration due to gravity is about 1.6. So that is why there is no air resistance, and therefore people will find themselves like floating. Okay, great to see. Is this one okay? Okay, take your information on the handout that I gave you. You finished copying that thing? Alright, to the pilot students, this is the, probably you can quickly draw a table down, and then you just copy this information. One side will be the body, and then you have the acceleration due to gravity on the next side. Right, just fill it in. Earth is 9.8, the moon will be 1.6, Mercury is 3.7, Venus will be 8.8, and you have Mars, which will be 3.7, Jupiter will be 24.9, Saturn will be 10.5, Uranus is 7.8, and Neptune is 11.8. Okay, how many planets do we have here? 1, 2, 3, 4, 5, 6, 7, 8. What is the other one? Pluto. Okay, why do you think there is no information given for? Okay, probably it is far away, so we cannot get the acceleration to the gravity for this. But probably in the future they might give us an information on this Pluto. All right, we will move on. Once you have copied this table down, you have this information. Should be this one should be M. Okay, small letter M. M equals mass and not K. Finish. Activity number 1. question 2. Please copy that as well. Can you go to the downstairs office and then you get the spring balance and then bring a part room scale, the one that you stand on to measure. Can you just do that now because we in this lesson. Let's have a look at the third question. Okay, let's move on to question number 4. This is question number 4A. Still on the train, take your weight. What do you mesh? 50. person's weight on the moon is 900 newtons, where acceleration due to gravity will be 1.6. It should be 1.6 meters per second square. What is a person's weight on the moon? All right, for number 4A should be the person's weight on the earth is 900 newtons, where acceleration due to gravity is 10 meters per second square. Right, what is a person's weight on the moon? All right, for that question, probably we'll find out whether someone has a weight which is 900 newtons. Nathaniel, you come. Let's measure and then see if your weight is 900 newtons. All right, Marvin, you come and take the reading. All right, that is a bathroom scale. All of you can see what is it. Come. Everyone has not. Come, you stand again and then. All right, pilot students, this is our person's. What is it? Is it in newtons? Kilograms. Okay, it is 90 kilograms. Nathaniel is almost about 900. All right, newtons. He has a force of 900 newtons, especially on Earth. All right, what will happen if he was taken to the moon? What is the weight? All right, that is question number 2. Question 4. Right, this is a bathroom scale. It is not to measure the force. It actually measures it or takes the reading in kilograms. It takes the mass or reach the mass of an object. So using this mass, you can put that into Newton's second law of motion to come up with the weight. Right, you can start working on those questions. I'll give you 2-3 more minutes to do that, and then we'll come back for the answers. mark for each one of those already. Finish. 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 Number one. Finish. Mission. Okay, for question number one, we'll have Michael. Fellow students, we are now on to our answers for those problems. Michael?
Question one says calculate the weight of a 65 kilogram person on the Earth's surface where the acceleration due to gravity is 10, and B on another planet where the acceleration due to gravity is 5. Okay, in A, on Earth, using the formula weight is equal to mass times acceleration due to gravity. The mass is 65 kilograms, and you multiply that by 10, which is the acceleration due to gravity on Earth, and the weight of the person on Earth should be 650 newtons. On another planet where the acceleration due to gravity is 5, his mass, which is 65, multiplied by the acceleration due to gravity will give you his weight, which is 325 newtons.
Is that answer correct? Is that answer correct?
Yes.
All right, good. We will go on to question number two. Number two. Okay. Samantha, question number two. Two.
question is asking for the person's weight. To get the person's weight, you multiply the mass, which is 70 kilograms, by the gravitation. Acceleration equals 9.7 to get our 600.
All right, is the answer correct? Yes. Okay, for number 3, what is the weight of a person of mass 100 kilogram if not a person, this time it is a satellite, in an area of space where there is no force of gravity? Isaac, what is the weight?
Uh, 150 newtons.
The weight will be
150 newtons.
100,
150.
350. Garrett, what do you think? What is your answer? There will be no force, right? Simply because the acceleration, there is no force or acceleration due to gravity. Therefore, the force will be 0. Okay, the person who gave us a mass of will have to explain this answer. Nathaniel? Right, you weigh 900 newtons on Earth, where the acceleration is 10. What is the person's, oh, what if you were taken to the moon? Okay, what is your weight?
For question 4, the person's weight on the Earth is 900 newtons, which is also equal to 90 kilograms. Using the formula, weight is equal to mass times the gravitational acceleration due to gravity. You get 90, which is the mass, times the 1.6, which is the acceleration due to gravity on the moon, and you get the weight in newtons, which is 144.
Okay, good. So he has given us his mass as 90 kilogram, and if we were to calculate the weight, it will be 900 newtons. Now, if he was taken to the moon, that is 90 times 1.6, that is 1/6 of the force of gravity on Earth, and then we should get 1.4 or 144 newtons. All right, to our last question, what is the mass of the person's weight on the moon? All right, the mass will be? What will be the mass?
The mass would be 90 kilograms.
Okay,
On
the
the-
mass will be 90 kilograms. It won't change either. Only the force will have to change because of the acceleration due to gravity. The mass will remain the same. All right, so we will now recap the lesson, and that is when we'll be asking one of our students to just give us a summary of the lesson. Malcolm.
As we have learned, mass is the amount of material in an object, and weight is simply the force. The weight of a person depends on the gravity, and the mass of an object is constant, but its weight varies due to the distance or altitude towards the center of the planet. In order to calculate the weight, we use weight equals mg, where m is the mass and g is acceleration due to gravity.
Okay, the summary was well explained and is quite clear. And that brings us to the end of the lesson. Our key phrases: force and gravity. Good afternoon, pilot teachers and students, and good afternoon, model class. Thank you very much. You may sit down.